Good morning, good afternoon, good evening, and welcome to our Tech Talk. My name's Tobias, and I'm on behalf of the Arm AI ecosystem team. I'm thrilled to welcome you to our the latest in our AI Virtual Tech Talk series. This series is all about bringing brilliant minds together around the world of AI with live demos, workshops, talking about the latest trends, the latest technologies, and best practices. And we bring together speakers from Arm as well as speakers from our AI partner program to this. And one of those is AI Technology and Systems, AITS, and we're thrilled to have them presenting today around bringing PyTorch models to Cortex-M processors. So don't forget, of course, as part of this, you can not only ask questions in the Q&A box. For those of you who are regulars to this series, you'll know all about that. Any questions, just whack them in the Q&A box and we'll answer those at the end. But you can also tweet us. So you can tweet us at Arm Software Dev. If we check out the next slide, thanks Rohit. And you can tweet us at Arm Software Dev with the hashtag AIVTT, or just tweet us and we'll catch that and give you guys a retweet. We're really excited to hear your thoughts on this. You can also watch the recording of this. We'll be posting the slides and the recording of today's presentation on our software developers YouTube channel within about 24, 48 hours. So do check that out. If you've missed any bits or you want to catch the guys' demos again, then do check that out. And of course, you can also sign up for our next AI Virtual Tech Talks as well. I'll be pasting a link in the chat in just a moment, but we've got a whole host of tech talks coming up over the next few months. So we've got optimized C code generation for tinyML in 2 weeks from ImagineMob. We've got a great couple of talks in June as well around production and efficiency in manufacturing, and one from our APAC partners, actually, Nota AI, on their Nespresso technology. Before we've got a fantastic jam-packed July, as it were. We've got 2 tech talks in a week on July the 30th and 20th from Arcturus, NXP, and then Arduino. I'll paste the link in the chat in a moment, but we've got a really cool URL we've just added recently, developer.arm.com/tech talks. Head to that, sign up for upcoming tech talks. We'd love to see you there, and we'd love to hear from you. So today's tech talk, let's get back to today's tech talk. We've got AITS presenting today. We've got some fantastic presenters. I'm really honored to have them as part of our tech talk series today. We've got Rohit Sharma and Praveen Jain from AITS presenting. And I'm now going to hand over to these guys as they're going to talk you through all about their technology and PyTorch on Cortex-M. So finally, before I do that, actually, remember to ask your questions in the Q&A box. We'll catch those at the end. Without further ado, Rohit, over to yourself.
Thank you, Tobias. Hi, guys. Hi, everybody. I'm Rohit Sharma. I'm a second-time entrepreneur, CEO of AITS. And with me, I have today CTO of AITS, Praveen Jain. Praveen?
Hi, everybody. My name is Praveen. I'm CTO of AITS, and I'm very glad that you guys are here and looking forward to your participation.
Thank you, Praveen. So with that, let's get started right into the agenda. And so what we're going to do today is to introduce our technology, the problem that we are attacking, and the solution at a very, very high level. And then we get into the complete tinyML platform with a couple of products, no-code app development IDE and full-code app development IDE, followed by a bit on compiler development. So these are the 3 main topics of the talk today. You have questions, please, like Tobias said, continue to ask them in the Q&A dialogue, and we'll pick it up as and when, mostly after the talk. We will show you the demos on our platform and how to bring this whole application on Arduino NanoSense PLE that you see in my hand. So there are 3 demos. We will bring one of them on the microcontroller. With that, let me move on to the next slide. So what are we solving? We actually are bringing complex AI model onto tiny devices on ARM boards and microcontrollers. Bringing complex AI models is a difficult proposition, and the complexities range from picking the right framework, whether it's a TensorFlow or PyTorch or something else, finding out how big is your model, whether the model fits in your microcontroller or not. If it does not, what are the choices? Do you go about optimizing it? Do you change your microcontroller, and so on and so forth? So it takes a team of data scientist, embedded developer, IoT engineer, and so on and so forth to bring the application to life. And we are making it as easy as bringing your board once you have decided on the microcontroller with Arm IP. You connect it to our platform, and we help you through the rest of the way. We have no-code platform and full-code platform. No-code platform, you can bring the AI model and application without writing a single line of code, and I'll give you the demo of that. And if you happen to have a team or one engineer with data science background, a bit of embedded development, we provide all the bells and whistles ranging from IDEs, languages, libraries, compilers, and everything in between. You can continue to stay on the platform and develop the entire application and download that. So as a company, we are uniquely positioned to help Arm users and customers to bring AI models on microcontrollers, developing AI applications with our products and services, and also bring a new compiler to life if you happen to work on the hardware side using Arm Cortex IP. And we have over 70 AI models in our gallery. If you go on the link tinyml.studio, hit the gallery, you will find 70 applications that you can quickly compile and download for your microcontroller of your choice. Or you can use the proprietary model platform with full code IDEs. And if you happen to work on a new IP, new hardware IP, we have good amount of experience on bringing a compiler to life. We can help you there. There is an open source IP that is available on GitHub. You can go check that out with DeepC. So this is our products and services, and we would love to help you. If you have any questions, reach out to us using www.aitech.systems or email us. So no code AI development. Now, there are two flavors to that. We have a gallery, like I said, of AIoT app stores that you can go and browse and download one of those. And those are models that you have, we have trained for you. You can compile them to the microcontroller of your choice and just hit download. The download starts automatically and you're good to go to use that. And the second version of that is you can customize that with the playground. And what I mean by that is you can collect or create your own data sets and plug that data set, that customized data set to the notebook or the model, train it, and we'll give you the compiled version that works for your choice of microcontroller. And with this, you don't have to write a single line of code. You just press few buttons and utter a few words or capture a few images or collect the data from your sensor, create the data set. Everything else is just clicks and touches. And this is the URL if you want to explore our gallery, bit.ly/AIoT-apps. There are over 70 applications on our platform, hosted on our platform. You like one of those, you can start playing right away by clicking to edit and compile. So there are over 70. We continue to work on those. It would by the end of next quarter, we'll have over 100. Here is a brief platform demo. So let me go to give you the demo. And I'm going to switch my screen here. This is our platform. And I'm going to choose wake word detection. This particular application is essentially like Hey Google or Hey Alexa type of wake word detection, where it listens to your command and does the needful. And so in this demo, what I'm going to show you how easy is it to customize it to your needs. So you have a new keyword, let's say, hey Tobias, hey Rohit, or anything else like your product name, you can do that within few clicks and download the binary. For this demo, we have worked on keyword wow. So I'm going to give you the demo how that works. This is a hot word dialog. Now what you do is press the record button and say that hot word few times, like wow, wow, wow. And it goes on for like a minute. If you are looking for a POC or a prototype with 60-70% accuracy, you give us 60-70 samples. That's good enough to get started. And this particular one is anything but hot word. So it could be a dog barking or me speaking or reading a passage or a newspaper, which does not have a hot word. So this is your negative speech samples. And with these two, what you do, you hit train, and depending on the samples, it would take anywhere from 30 seconds to 2 minutes to train. And once it is trained, you come to this screen, which is the model is trained. Now you can test and find out how good is your model. And you can go back and forth to tweak certain things like increase the size of your data set and see how much accuracy you get and stuff. So I'm going to test this. And this particular keyword is wow. Wow, today is May 11th. This is fantastic. We are testing the hot word detection. Wow. So with this, and I hit test with this model, the next screen, this is going to take us to the display of the audio waveform that it has captured, and it would highlight in the green bars the region that it has detected for the hot word. So this is what I recorded live, and this is my speech sample. I'm going to play it for you. Wow, today is May 11th. This is fantastic. We are testing the hot word detection. Wow. So this is these two regions that you see here highlighted in the green bars is basically the region where it has detected the word wow. Now, if you're not satisfied, you can go back and do that all over again, increase the size of data set and change few more things, and come back to this screen again. At the end of the training, it tells you exactly what kind of accuracy you're getting. So if you get 70%, you can increase that to 90 by increasing the data set and data set size and so on. And once you're satisfied with the accuracy, all you do is you pick the framework and the board. For this use case, we are using Arduino Nano 33BLE Sense, and we are going to download the entire binary that can be flashed onto the board that you see in my hand. So this is Arduino Nano BLE Sense, and I'm just going to compile. By the way, while we are on this screen, you can also choose TF Lite Micro in case you would like to develop using that. And let me press the button compile, and it takes some time. By the time it is done compiling, it will download the binary, and that is flashable. So any minute now, model compiled successfully, and here in the corner of the browser, you see the binary is already downloaded. So for this demo, I already have the binary flashed. All you have to do is to take this binary and flash it on the microcontroller that you see. I'm going to connect this and show you the demo working on the board. So this particular application will flash the light in green when it detects the keyword wow. Otherwise, it'll stay red. So that's the function of this application. And I'm pressing reset now. Wow, fantastic. Wow. Today is AITS Tech demo. Wow. So, you can continue, and it will give you the signal that it has detected the keyword. And that's as easy as that. Bring your board, download, click few buttons, download the binary, flash it onto your device, and within half an hour to an hour, you're ready with your microcontroller that works and gives you the desired output. And so this was no code demo, and we would continue to develop more application as and when we find interesting ones. We have a couple of more for you to try: visual wake word and face mask detection. We would be bringing more sensors and boards to you on this platform. If you have an interest in particular board or a particular application and it happens to be popular, we will take the requests and see if we can do that for you. With that, let me go back to the presentation. So this was no code demo. Now, for the full code, if you happen to be a programmer, have interest in data science, or you are an embedded developer with a little bit of knowledge of Python, or either one of these two, you can use our full code AI development platform. It's entirely flexible. It gives you all the bells and whistles, makes you more productive with the tools we have on our website. And just to showcase you for the guys who are not aware of how the development goes, generally these models are developed for on large machines. And we are bringing these models to smaller, tiny devices, and that requires a different kind of software stack. And this is what we have focused on. Our niche, our focus, our forte is those tiny devices. So we have developed everything from compiler to rest of the tools. And the development flow on bare metal devices or RTOS looks somewhat like this, where you start with the hardware, like we picked Arduino Nano in this case. You acquire the data, train the model, and analyze the model, validate and test. Once you're satisfied with the accuracy, then you go on compile the model and continue developing the app in the platform. And once you're satisfied with the entire application, you compile the application, you flash the app, and you monitor the device like we did in the last demo. And so we actually have automated 7 out of those 8 steps. Once you have chosen the board, you come with the board, plug it in our platform, and there you go. That's all you need to do. The rest of the tools and softwares are on our website, on our platform. And we have a differentiation of a compiler, DeepC. This is a proprietary version. And we also have an open source version of that on GitHub, which is fairly popular, being used by several companies and users. You can check it out. If you Google AITS DeepC, you can find the link to that repository. So it's an end-to-end platform, no setup needed, cross-compile, we have gallery, and like I said, it's as easy as bringing your board to the platform. It does the rest. And it is an end-to-end development, full stack, meaning you can connect the board, and based on the kind of board, we actually provide SDKs to acquire the data. And we support anomaly detection, audio, vision, and sensor fusion. And once we detect or you tell us what kind of board is it, you can acquire the data in our platform, just like any other IoT dashboard. Once you have that, you can create a data set out of that. And this is for data sciencey kind of engineers and programmers who have that knowledge. And you can create the data set. Once you have the data set, we provide all the frameworks in our platform, starting from TensorFlow and PyTorch and Keras. And once you have that, once you have trained and tested your model, you save the model and we support all kind of formats, including TensorFlow, PyTorch, Keras, Onyx, Caffe. And once you have saved the model, the next step is to compile the app. And we actually provide a couple of tools. One is our own that we develop, and we compete with TF Lite Micro, which happens to be an interpreter. Ours is an ahead of time compiler. So by comparison, we save you quite a few CPU cycles, and we are better on RAM and flash size. But for whatever reason you happen to like TF Lite Micro, we have given you that access as well. And we are not tying you to our version. If TF Lite is better, let the better product win. And so we give you the access to TF Lite Micro. And once you are done with that, you compile that to the microcontroller of your choice. Any Cortex-M series type of IP with the board from ST or Arduino or NXP or whoever have you, you can download the app and flash it. So these are the 4 steps, and here I showed the formats and frameworks. Now, how does that tie to our platform? Is on this screen. You acquire the data. We have a feature called Palette, which lets you upload the entire data set. You can upload image, you can record audio, you can record video, and you can also register your device with other sensors. This is the latest feature. If you go on our website, you will find another one where it says sensor data. You can either use HTTP or MQTT protocols to directly record your data. So we give you everything to acquire the data. And once you have, then for training the model, there is an open notebook server that you can start with a powerful machine with GPU running in the background, which typically lets you train any type of model which is reasonable enough that can be brought to a microcontroller within 20 minutes. And also the gallery and the compiler. The next step is compile app, and we provide compiler whereby either you have it in the project or you can upload the model and we would compile it, and finally you download and flash. And so these are some of the features that I'm going to show you in few slides, and then we will go to the demo where I will showcase the how to develop the model in the PyTorch and compile it to the model of your choice, or the microcontroller of your choice. So we have Python and C++ notebooks integrated in the platform. And on practically every screen, you will see the compile button, be it in the notebook, or there is a standalone screen or dialog you can see where you can upload the file and compile it if you're just into the compiler. Or for every model that we have on our website, there is a corresponding article that you can go read and find out what this is, what kind of data set it takes, how to modify that, and how to work with it. And if you have questions, you can always reach out to us. So, Python and C++ notebooks, compiler and articles, and you can also clone and share if you have. If your work is open source, you can bring it to our platform by simply typing, copying, and pasting the URI of the repository. And with that, let me go on to the full code demo. And here, I would showcase how would a programmer use the platform. So this is, you go onto the dashboard. Once you log in, you typically are taken to the dashboard where you click this, and that starts this notebook server. And there, you can either bring the notebook from outside, or you can start developing your own. And these are the, here, if you click, it will let you select the preferred kernels. And like I said, we support Python and C++, flavors of C++. In this case, this is, excuse me, this is a Python notebook, and the application we are developing is American Sign Language. And the data set is collected with the gyroscope. It's the same board that I used before. Earlier, it was using microphone. Now it is using accelerometer and gyroscope to collect the data. And for those of you who are not aware what American Sign Language is, what are the signs, how, and what's up, or how are you is, this is how mute people say hi. And this is how are you. So we have taken a couple of those gestures and created the notebook, in particular, hi and how are you. This is what we are collecting the data on. And this is all using PyTorch. So if you're interested to get access to this notebook, feel free to log on to our server, and it will show you it'll show you the ASL training, and you can just clone it in your user space and start with it. So what we have is we have already collected the data set in hi.csv and sub.csv. Now the next two sections will be, it's basically, displaying the hi gestures for accelerometer and gyroscope. This is accelerometer, and this is also accelerometer for SUP, and this is gyroscope for hi, and this is gyroscope for SUP. And this is your network. I'm not going to go into the details of that network. If you're curious, go ahead and log on and find for yourself. And this is how you train the model. So very small and simple model using ReLU and fully connected layers. And this is where the training happens. And if you see, this was already trained. The loss in this continues to goes down. That's what a data scientist would look for. The accuracy should be close to 100% or 90+%, depending on your expectation and the data set size. And once you're satisfied with that, you go ahead and evaluate. And in this case, our test accuracy is also 100%. So once you're done with in training this model in the notebook, you save it. And in this case, we are using PyTorch and develop that in PyTorch. PyTorch has a feature to export the model in Onyx. And this is what the Onyx graph looks like for this particular application. Now, for this model, once you have the Onyx model, now comes to the compilation part, which is as easy as showing a command of deepcc. Deepcc is a command for our DeepC compiler, and you give it the Onyx model. By default, it will compile it to the Linux version that the server is running on. If you want, there are other options specifically designed and coded for boards that we support, including Arduino Nano, ST, and some of the other boards. So you can simply say board and provide the board name, in this case, Arduino Nano or whatever. I'm not going to do that. In this case, what you see is this is compiling and also optimizing it for the underlying machine. And final binary size you can see is about 167 kilobytes. And you can run that. The advantage of using this another advantage of using this is you can debug and make everything ready on Linux for the developers who are comfortable with Linux more than the bare metal. And once you are satisfied, you can add another switch for the microcontroller of your choice, and it'll cross-compile for that particular board, and you're done. Now, this is just a model. So what we also provide as an intermediate code step is access to C++ code, depending on your license. And this is how you convert the model, Onyx model, to a C++ code, and which is available right here. I am not going to go through this, but if you are curious, we can talk about the entire process. And this is typically where app developer will take this model and continue to develop in the platform itself with writing additional glue code that makes the application entire, that makes the entire application complete. And once you're done, you just hit compile and download the application as binary. So this was our full code demo. In the next few minutes, I'm going to go through the compiler, which is under 2 minutes, and then we will take questions. Our core technology is DeepC compiler, which takes, like I said, any format: TensorFlow, PyTorch, Keras, Onyx, Caffe. We have several optimization algorithms and scheduler, which optimizes for the underlying hardware. When you provide that switch, either board or with more switches for embedded systems, then we understand how much memory do you have, how much flash do you have, what kind of processor do you have. So we actually do a few optimizations to make sure that code fits into that flash space. And when it is running, your peak memory does not go beyond what is available in the system. And we provide a BLAST library, DeepC library, that's homegrown, indigenously grown. It is generic library. If you happen to have customized version of let's say, a latest and greatest accelerator, hardware accelerator, and you would like to optimize to that platform, you can talk to us and we can customize this entire compiler chain for your hardware. And as an intermediate code, as an intermediate step, we also provide access to WebAssembly and C++, and you can finally compile that to static binary, static library, dynamic library, or the binary of your hardware. We support all TensorFlow, Keras, PyTorch, Caffe, Onyx. We were the first one to bring MCUs on PyTorch models on MCUs back in December 2019. We still remain the only vendor providing PyTorch model to microcontrollers because we have this indigenously homegrown VC compiler. We support all platforms, all ARM series, M3, M4, M55, you name it. And it works flawlessly on that. We support bare metal, FreeRTOS, derivative of Linux, and also Linux and Mac OS. Output we've already talked about. Deep C operator support, we currently have over 120 operators in Deep C as opposed to 53 in TF Lite. So we are slightly better. In some cases, few instances, TF Lite does not support RNN and LSTMs. We have helped customers and users who have models using some of those operators. Our optimizations are targeted for low power, flash size, peak memory, performance, and accuracy. So we do quite a bit of pruning before, and then we have a scheduler that works with bringing the parameters ahead of time to CPU from flash. So we have a little bit of optimization and scheduling in that. Also provide network profiler. By that, what I mean is if you are debugging your network, finding out how you can reduce the size in case it doesn't fit, we provide all the CPU time, user time, and the RAM each layer takes. So if you are going in the loop of finding out how do you optimize your own network, this comes in pretty handy. And this is a use case that is available in public domain. It's a very interesting use case that we are working with one of the large federal agency. And what this does is it has a software defined radio, and that radio scans the RF band to find if there is a human inside a confined space like a building or battlefield vehicles. So the application of that is in case of natural disaster, let's say earthquake, the building is smashed to the ground and they want to find out if there is any life inside that rubble. This is a simple board that you can carry with you, 5 centimeter by 3 centimeter, has antenna, has a radio, and the model actually works to find if there is a human inside or within that range. And it works on human sensitive RF bands, scans those, and will give you yes or a no, and also approximate distance from the board it has. So it's a very interesting application for first responders and our soldiers in the battlefield, where access to electricity and connectivity to internet is a luxury. And so you do not want to depend on any one of those. It works on battery and requires no connectivity whatsoever. A couple of more use cases. And in last 30 seconds, let me give you the demo for the compiler, how that works. So you go on, and if you have a model already, you choose the file, and let's say I'm going to upload this model, and I'm going to choose framework as this, and let's say I'm going to compile it to Arduino. And this is, I want to download that as a static library. So I compile, and it would be done in a few seconds, and it'll start the download automatically. And model compiled successfully, and now you have ASL model.zip. And this is what the content of the ASL model looks like. So you have a header file that you will have to include, but how do you use this lib ASL model.a is present in the README file that is downloaded along with the entire header files and .lib. So it tells you the sample code, gives you the sample code, and this you can practically cut and paste and put it in your application if you happen to use only the compiler side of it. With that, I am open to questions.
Thank you so much, Rohit. That was awesome. And I'm really glad the demo gods shined favorably on you doing live demos. Although they didn't shine on me when it came to my ability to unmute myself, very much. I think I compensated for you guys having a great demo opportunity. So thank you for that, and thank you for a great presentation. And we've had loads of questions come in, and thank you for submitting them all. If you've got any other questions, doesn't matter how. If you think that even the question you think is a silly question, don't hesitate to ask. We're absolutely open to all of them. We've got about 14 lined up, so I'm going to try and group a few together. And one of you guys can absolutely take this by all means, pick whichever one you feels best. Looking at the stack, one question was around pruning and quantization, and they weren't clear if there was any. I did see it very briefly mentioned at one point. So there was a couple of questions around how you do kind of the model optimization, conditioning, quantization, pruning, etc. In the system you've got. Would you guys mind elaborating a bit more on that?
Praveen, you want to take on that?
Sure. So there are two, ways you can optimize your model, to fit to your target device, right? I mean, during the training, you can do, quantization, or quantization, training-aware quantization and things like that. And additionally, in our compiler, we do have optimizations implemented. Everything from constant folding to loop optimizations to dead code elimination, among other things. Light insert analysis, etc. To optimize for the flash size, the peak RAM utilization, and for CPU cycles. So, go ahead, add anything else?
Yeah, thank you. So to add to Praveen's comments, we do have quantization directly in our compiler. And we do have access. So when you provide the board type, we know what kind of data types are supported. And if, let's say you gave us the model, which is floating point 32, and it doesn't fit, we would automatically choose one of the quantization types to reduce the size. So that's to add on to his answer, that we have quantization in our compiler, and unless you want to force quantization, you can provide a switch that this is the type of quantization we're looking for. If not, based on other parameters, like if we are looking to reduce flash size or peak memory, we might go for that and tell you, hey, we have already pruned this model to int8 because the size is about 1.7 megabytes and it doesn't fit in the flash of 1 megabyte you have. So in some cases, we decide that automatically. In some cases, you can override that.
Thank you both. Great answer. And I think you've kind of covered a couple of questions there on the pruning side. By all means, if you want to answer further those, please do type the answer in the Q&A box. A question came in around all the boards you support. There are a couple of those in terms of hardware support you mentioned around Cortex-M and Cortex-A, etc. There was questions around, there were only a few that seemed to appear in the drop-down list when you showed them. How do people kind of add to that, right? How do you add and say, I want to compile for this particular board, et cetera, as they're looking at? There are a couple of questions around that, if you wouldn't mind expanding on that.
So sure. We actually support most popular microcontrollers. So if you have a favorite one, then you reach out to us and state your reasons. These are the set of microcontrollers we support today. We will continue to increase that list. And of course, it's not exhaustive by any means. All of them are ARM. They have ARM IP. If you happen to have a favorite that you would like us to add, come talk to us and bring your project, the reasoning, why would you want that board and stuff, and we can make that happen for you. we generally work with vendors. We have, the ecosystem, and we partner with most of these MCU vendors that give us some of that knowledge. So, we three, you as a customer, we as a provider, software provider, and MCU vendor as a hardware or the board provider can work together to support more boards on our platform.
Thanks, Rohit, for that. I think that's great. And there's been a few questions come in again on pruning, and I think we've covered them, but just to make sure everyone gets the response they're looking for. So they've asked around the kind of pruning that your service offers, how you control multiple rounds of pruning, because that's important for, of course, throughput optimization. And then after, one of the questions is, after we run pruning, we would need to do fine tuning to recover the performance. Does the platform enable implementing that?
Yes. So if you want to work in the loop from training all the way to your hardware, typically you would have to have a loop that goes from the data set all the way down to your hardware. And if you have this entire loop, what research has shown that the quantization is most effective when it is done during training. Typically, you have access to high-end server, which tracks most of these weights and their quantization graph, and does a much better job than the one without compiler. So generally, the difference we have observed between the during training quantization and post-training static quantization is about anywhere from 1% to 4%. So if that 1% to 4% is very important to you, you have to have that entire loop. Typically, that is used during creating a product or productization loop. If you're creating a POC, under 5% is typically not something that you would want to worry about.
Thanks for that. And then I guess on back to the custom or the hardware question. So I guess it's a case of, as you say, getting in touch with yourselves, because people are saying they've got their own hardware using M3, Cortex-M3. How do they get that onto the platform, and kind of using their own Cortex-M based, boards as such? I guess getting in touch with yourself is the best way to go about that. Would that be fair to say?
Yes. So if you want the entire binary, you would want to get in touch with us. And if you are just looking for a static library based on ARM IP, we don't have to support the board. Like, you have a board that our platform does not support, then you provide us what kind of IP you have, and we can work together to come up with the right set of options to the compiler that gives you a static binary that you can go offline on your IDE and develop that. So what I'm saying here is, if you're looking for just the model, we do support the entire world of microcontrollers when it comes to ARM M series of devices. But if you're looking for an application, then we need to support that from scratch. And we can work with you and the MCU vendor on that. But yeah, getting in touch with us, and finding out more. I mean, we would love to find out about your use case and what are you working on. Some of the things that are coming up are very, very exciting to us, like the use case that I mentioned, and I can go on and on and on. We are also working in the smart space, where you don't have access to electricity or internet, and there things get very interesting. The kind of use cases that come on are they're just magical. So talk to us. Maybe we can give you ideas. You can give us ideas. For microcontrollers support, definitely come and talk to us.
Thanks, Rohit. That's great. Yeah, real wide range of Cortex-M support is great. We'd love to hear that, of course. So there's been let's kind of jump to a couple of other questions, and please do keep them coming in. We've got loads of questions to answer, so I'll try and get through them quickly. Are all types of models from PyTorch supported on this platform? Is a question that's just come in.
Absolutely. So we can give you the list of the versions of PyTorch format, TensorFlow format, Onyx. On the top of my head, the answer is yes. And we do support everything that is released recently. And the number of operators we support by far, beat our competition and any other provider. So if we don't have a version that we are supporting, we will do that in a couple of days. So we are committed to bringing all frameworks on microcontrollers. That's our forte.
Thanks, Rohit. And a quick follow-up question on something slightly different. Have you, and hopefully a quick answer from you guys, because it's quite a good question though. Have you been using, or have you used Arm Synthesis NM software library on the for these Cortex-M based devices?
Yep. So we do support ARM CMSSNN and other board libraries provided by the vendors. So we have that support.
Thanks, Prithvi. Thank you. What have you guys seen as the biggest challenge, as questions coming from Annie? What's the biggest challenge you've seen moving from PyTorch to the MCU driver?
The biggest challenge is, the framework itself is not focused on tiny devices yet. So generally they are not very careful when it comes to the size of the model. So we find many opportunities for optimization in the models that come from PyTorch or Caffe. And some of the differences, for example, PyTorch for vision models has different convolution order NCHW for the data science guys who understand. N is the number of frames, C is channel, H is height, W is width. That's what's supported in PyTorch as opposed to TensorFlow, which is NHWC. The order is flipped, and in some hardware, one format is better than the other. And we understand that natively based on the information we have on the board. And we do transformations of these layers without you knowing, because we understand what kind of hardware, what kind of metrics multiplier is there on these boards, what kind of vectors we can process. So with that information, we prefer one over the other. So there are challenges on operator size, the size of the binary, size of parameters, and so on. And also the support. The operators, if you happen to use one of the not so popular operator that is only present in PyTorch, there is no way you can bring that to TensorFlow and stuff. So there are differences in the operators, the way they are implemented, their options. So that is as developers and supporters of all the platforms, that remains our challenge internally. But this should not come to your attention. We do everything seamlessly.
Great, thanks, Rohit. That's great. And another great questions come in terms of the voice audio detect. What languages do you support for that?
So languages in the flow, when you're developing the model, it's the Python that's used. Now for compiling, we do have C, and that comes from the constraints, C or C++, that comes from the constraints, the type of version or C or C++ standard that MCU vendors support. C++ standard 11 is the most popular among MCU vendors, and we support that by large. So for the compilation and giving you the binary, it's the C or C++, embedded C or C++ is the language that we use. For training, it's Python.
And sorry, I wasn't very clear on the question. I think it might be related to, and apologies for my poor phrasing, in terms of the voice audio detect, is it English and French and German, Spanish, etc., or is it just English for that particular demo for the voice audio detect?
Yeah, so for that particular audio is the application is only English, but it's as easy as you can change that, use the same app, change to whatever you want. We are not limited to a language. So using the same demo I showed you, if you want to develop an application in, let's say, French or Hindi for that matter, say those words in whatever language you have, and we'll give you a model to detect that word.
Thank you. That's great. Have you tried, another question's come in, have you tried running higher end Cortex-A applications on a more constrained sort of Cortex-M and maybe even, you know, Ethos U sort of environment, M55, U55 environment?
Can you repeat the question, Tobias?
Yeah, sure. Have you tried, excuse me, have you tried running higher end Cortex-A applications on a more constrained environment, e.g. Cortex-M, Cortex-U, Cortex-M Ethos U environment?
Yes, so we have now Cortex MCDs. Generally, the boards, they come with a limited flash size and RAM size, typically 1 megabyte or 4 megabyte of flash size to 256 to half megabyte of RAM. And bringing a higher end model that's running in, let's say, Raspberry Pi Series A, Cortex A series processor, down to M series is a challenge, primarily because of the size. But you know, these M series microcontrollers, they are becoming better by the day. You know, ARM is working on M55 and Ethos, the accelerator. NXP is later coming up with that board. But if you have for vision models, particularly for vision models, the compute required is more. So if you want to maintain the same latency on M series, you got to give up some of the accuracy, and some of the optimizations that we offer can bring that model down to crossover MCU that has support for camera and image sensor, and typically those tend to be crossover MCUs with the two processors, M4 and a DSP, where you can offload some of the FFT and the convolutions on to the DSP to maintain the latency. And so yes, we have tried, and we have few use cases that are working on the vision and MCUs. Espressif board, ESP32 is one such example, and there are others.
Brilliant. Thank you. And I think just before we do kind of catch on the last couple of questions, you've got a giveaway you just want to talk about as well for all our attendees, in addition to the one we normally do. Do you want to quickly talk about that?
Yeah, so exclusively for the attendees of this Tech Talk, here is a URL, and Tobias, if you can, paste that onto the chat box or Q&A, that would be awesome. If you go to this URL, you get the pro version of Canvas, and this is limited in the next hour. So take advantage of that. You will see by clicking this link, ARM logo and AITS logo combined, and that tells you that you are on the right link. And once you click that link, you get better machines, more storage, and access to pro version of the software and the libraries that we have.
Awesome. So yeah, definitely go and check that out. And thanks, Rohit, and thanks you guys. Thanks to all of your the team for kindly agreeing to do that, because I think people have asked around typical costs of using the platform. I mean, you can quickly elaborate on that if you want to, but I think that's a really great giveaway. So do check that link out. Just paste it in the chat. So do you mind elaborating quickly on the typical cost of using the platform?
It's not expensive, is what I can tell you in this forum. If you happen to be a single user, definitely it's not expensive. If you are a small business, we can work with you. If you're an enterprise, you definitely have money and you want to talk to us. But typically for enterprises, we can white label the platform to avoid any IP sharing issues. And we also work with these large federal agencies where security and safety is of more importance. So we work with some of these issues. And so we work with all kind of customers and users, and the licenses go by your need and value. There is not one number I can give here.
Do you guys provide a learning platform as well? We've had a couple of questions on the kind of learning path and learning platforms for your solution.
I'm not sure if I understand that question. Learning meaning, is it machine learning or
I
is it?
guess as in kind of the, how to use all the different, how to use everything, the kind of path to get up and running with all your tools and various bits and
Yeah,
pieces
yeah,
in there,
sure.
guides, etc.
Yes, we have application notes and guides on our system, and of course, we have a fantastic support. And for no code platform, if you end up wanting that, then there is something wrong that we have done. You should not be, looking for help on no code platform. It's just few clicks and buttons. There's not much that you can do wrong. Trust me, you can't do anything wrong on the no code platform. If you happen to be a developer, then you might want more flexibility. And then we have a lot of flexibility in the system. It's just that not everything is obvious, and developers are tuned to that. So come talk to us, ask for help. We generally get back within 24 hours.
Awesome. Thank you so much, Rohit. So I'm really sorry, but I think we're at time. We're just coming up to the top of the hour and we've got to wrap up. So what I will make sure, though, is we'll get all the questions sent over to Rohit and Praveen that we haven't had a chance to answer. And what we'll do is we'll put on the YouTube and on the ARM developer page a kind of list of, we'll put some of these questions together. If you guys are happy with that, that we can, and you guys can write the answers to, if that's okay. And people who haven't had the chance to have their questions answered can then go and check that out. You'll get an email later this week with the link. Praveen, Rohit, does that sound like all good for me to get you guys those questions and you can answer them in the next few days?
Sure.
Absolutely. Yeah, anything to help you guys. Like I said, we are a company which is uniquely positioned to help our users and customers, and we love questions. You have questions on our platform, on our technology, or something else that you're working on, we would love to talk to you.
Get in touch with them. Absolutely, 100%. So thank you all very much. Thank you, Praveen and Rohit, very much again for doing such a great presentation with demos that the demo god shined upon you today. We're thrilled with that. And thank you so much for doing that. For those of you who are still on, just very quickly, as you end this call, as usual, you'll be entered into Arm's own prize draw. If you've been on our talks before, you'll know all about this, where we do a survey just to get your feedback on how you feel our tech talks are going. And if you enter that and if you submit a response to that, you'll be entered into a prize draw for Arduino Nano 33 BLE board, which you may have seen earlier, which is great. So also, don't forget to register for upcoming tech talks. We've got a little sneak peek coming up of something really exciting on our talk on the 25th of May. So make sure you tune on to that same time in 2 weeks. So make sure you tune in for that. We're going to have a great sneak peek right at the start of the talk. So make sure you tune in for that. It's Imagine Mob's talk. We've got a little sneak preview of something we've been working very hard on for a few months at the beginning of that. But yes, on behalf of myself, Rohit, Praveen, thank you all very much for attending, for your great questions, and we look forward to seeing you at our future upcoming tech talks. Thanks very much, everyone.